Okay, let's look at the homework 14, problem number 3. Alright, so we're going to use the spherical coordinates to find the volume inside the cone above the plane at z equals 2 and inside the sphere with the radius 6. Alright, so let's look at that. Alright, so to make the drawing a little bit simpler, I'm going to just draw the image on the YZ plane. Alright. So let's see, we're gonna draw a y-axis. So I'm gonna just draw a y-axis here. All right, and here is my z-axis. All right, so something like that. All right, and here I've just labeled these. Here's the z-axis. And here is the y-axis, right, and 0. Right, so the sphere is, so we can just, yz plane, the equation x equals 0, so I ignore this term. So y squared plus z squared equals 36, which is 6 squared. So radius is going to be 6. So I'm just going to draw a circle, center at the origin. And this is going to be a circle with radius 6, so maybe I'll just make it big enough. So something like, let's see, something like that, right? And you see that this is radius 6, so it's 6 here, and a negative 6 there, and 6 there, right? So it's going to be inside this circle, right? Then you have a z equals 2, so 2 is going to be somewhere like 1/3, so it's going to be 2 is going to be around here, so that's 2, right? So you have so I'm going to just draw a straight line there, so it's probably around like this. So above this line, right, then inside this sphere, and also inside the cone, right? So this cone, what we're going to do is set x equals 0 so that we can see the image on the YZ plane. So you will get 3, so x equals 0, whoops, right? Set x equals 0. Then you see that this equation is going to be 3z squared is equal to y squared, right? And I'm going to solve for z, so divide through by 3, and you have a z squared is equal to y squared over 3, right? Then take the square root of both sides. So z is going to be plus or minus, right, 1 over square root of 3 y. Alright, so the slope is 1 over square root of 3, so it's going to look kind of like this. Right, 1 over square root of 3, so it's 30 degrees. So the line is going to look something like this. So I'll try to see if I can draw it precise enough. So something like that, right? So right, you have to go through there, right? So we have that. All right, then the inside, actually we have to draw this side too, so maybe I'll just draw it like this. All right, oops, it's kind of, all right, so something like that. All right, actually it looks kind of, actually it's not, I'm gonna do my do a better job. So it looks more like this, right? All right, so this is going to be inside, so I'm going to say shade the region. So this is the region we have, right? Then we're gonna turn this into a three-dimensional object by adding a little bit of depth here. So it's gonna look something like this, right? So here, and you have a circular cross section around there, right? Then around here you would still have a circular cross section there. Oh, actually that doesn't look very good. So more like this maybe, right? Right, something like that. Right, so I'll just shade this so make it look like this is looks like a ice cream cone with the bottom kind of chopped off. So you have, right, so this is the three-dimensional object, right? So maybe I'll shade it kind of like this, like a dome, right? So it looks like that, right? Alright, so what we need to do is we're going to use the spherical coordinate to set up a triple integral, right? So let's do that. Alright, so it's going to look like this, right? So the volume V is going to be equal to, alright, so we have triple integral. Alright, so volume element for spherical coordinate would be r squared sine of theta, right, dr d theta d phi, right? Alright, so we need to find r here, right? So it's actually kind of hard to see. So let's focus on this region right here. Right, so this is the region on the xy plane, yz plane. So let's focus on this region right here. Right, so let's fix theta and phi. Then you look at the so angle is fixed, and theta, so two angles are fixed. So r is going to go from this point to the sphere, right? So for fixed theta and phi, r is going to go from this the bottom, which is z equals 2, all the way to here, right? So we have to somehow express let's say r from here to there, right? So r is going to be right, r here, right? This is easy because this is the edge of the sphere. So r, in this case, this is the same equation in spherical coordinates. It's just r is equal to 6, right? So this right here is a sphere, so we know that the radius is equal to 6, right? So we know that the upper bound is going to be 6, right? Lower bound, we have to figure it out, right? So to find this length r here, and this is z equals 2, right? Right, remember that z equals 2, right? You can write it as, right, z is same thing as r cosine of theta, right? Cosine of theta. So this is equal to 2, right? So which means that let's see, r is equal to 2 over cosine of theta, right? So this right here is R equals 2 over cosine of theta, right? So we have so 2 over cosine of theta, right? Then the theta is going to go, so once you have this segment, you can change the theta so that we can cover this entire region, right? So start from theta equal to 0 would be just a segment here, right? So this is theta equal to 0. Then you keep on increasing the angle theta, and here we have to go all the way to this edge right here, right? This is 30 degrees, so theta is going to be 60 degrees. So this is theta is going to be pi over 3. So theta is going to go from 0 to pi over 3, right? So that will cover this region right here, the shaded region right here, right? So the solid that we are interested in is going to be a solid of revolution. You can just spin this guy around all the way once. So phi is going to be, as usual, start from 0, then go all the way around. So that's going to be 2 pi, right? Then you can just evaluate this integral, right? And define the volume of that solid. All right, that's it. I hope that this will get you going.